Good morning, students. I am M. Venkataya, Assistant Professor in the Department of Mechanical Engineering at Vignas Lara Institute of Technology and Science. So now I am going to teach the subject is the thermal and hydro prime movers. So this is the third unit introduction. So this is the syllabus of third unit, that is the simple gas turbine plant, ideal cycle, closed cycle, open cycle, efficiency, work ratio and optimum pressure ratio for simple gas turbine cycles. And this is the another part of third unit, that is the actual cycles, analysis of simple cycles and cycles with intercooling, reheating and regeneration. Okay, so this is the third unit of THPM, that is the thermal and hydro prime movers. That is part 1 thermal prime movers and part 2 hydro prime movers. So we have to see here, this is the third unit, that is the simple gas turbine power plant. So we already discussed in the previous class, that is the steam turbines, as well as that before the first unit, that is the IC engines. IC engines means internal combustion engines is also completed. After completion of that one, the second unit, that is steam turbines. Steam turbine also completed. Now I am going to explain about the gas turbines. This is the part 1 case, and we have two parts is there. That is one part is thermal prime movers and second part is hydro prime movers. So the first part, thermal prime movers, is 3 units is there. That is one is the IC engines, second one is steam turbines, third one is gas turbines. So already 2 units is completed. This is the introduction class of third unit, that is the simple gas turbine plant. So already we discussed in the previous steam power plant. So how to use the steam power plant, and will the turbine will rotate, and then the shaft will connect it to the turbine. Then power will be generated. So we learn that particular power generation at that particular unit. Okay. Next, this is the simple gas turbine. So the working principle of simple gas turbine we are discussing here, and ideal cycle. So this is the ideal cycle, closed cycle, as well as the open cycle. We have discussed in the previous classes. The first unit onwards, we are discussing the open system, closed system, and as well as the isolated system. So in this unit, so same previous unit, that is the second unit also, we discussed the closed system and the open system, so like that. So in this unit also, the simple gas turbine power plant. So the working principle of working principle of gas turbine power plant, and the ideal cycle, closed cycle, open cycle. So the efficiency, of closed cycle as well as the open cycle and the ideal cycle. Okay. Then the work ratio and optimum pressure ratio. Okay. So the first thing is the work ratio. So work ratio and the optimum pressure ratio. Then for a simple gas turbine cycles. So for a simple gas turbine cycle, we have to see here, this is the simple gas turbine cycles, like ideal cycle, then closed cycle, then open cycle. These are the optimum pressure ratio. We are calculating here the work ratio after completion of that work, then optimum pressure ratio. So by using that, by using the simple gas turbine cycles, so the simple gas turbine cycles like ideal cycle, closed cycle and open cycle. Is it clear? Okay. Then this is the actual cycle, like analysis of actual cycle. We know that the actual cycle from this subject point of view in this unit. So ideal cycle, closed cycle, open cycle. So that is the actual cycle. We can call it as the actual cycle. That is the analysis of simple cycles. So analysis of simple cycle, like we talk about the analysis of simple cycle, that is ideal cycle, Second one is closed cycle. Third one is open cycle. Okay, so like that cycles with intercooling. So with cycles, ideal cycle with intercooling, that is a part one, that is intercooling. Intercooling. These cycles, ideal cycles have intercooling. Then the second one is reheating. So reheating. Then third one is regeneration. So we have, that is the cycles with intercooling. This is the part one, intercooling. Second one is cycles with reheating. This is the first one, second one, and third one is cycles with regeneration. So we have three cycles, that is the ideal cycle, closed cycle, open cycle. Okay, then so in this ideal cycle you have intercooling system, reheating system, regeneration system. Like closed system you have intercooling, reheating, regeneration. Then the open cycle have intercooling and reheating, okay, and regeneration. So we have three cycles. Each cycle have three parts. That is the cycles with the intercooling, reheating, regeneration. Okay, is it clear? Next, this is the overall description of third unit. That is the syllabus, and it is a very easiest unit. So when compared to other units, because of less syllabus, it is completed as early as possible. Okay, so today's class is that is the simple gas turbine plant. Okay, so the simple gas turbine plant, we have to see, this is the gas turbine. So the overall system of the gas turbine, systematic diagram for that gas turbines, and we have to see here, these are the blades, this is the gas turbines. So we have these are the all components regarding gas turbines. So in this we have to install in this this is called the shaft of gas turbines. When the gas will enter into the system, that blades will be rotated. Okay, so it suddenly enter into the system, so the blades will be rotated, and then the turbine have to fix the shaft. The shaft will rotate continuously. So then the shaft will continuous magnetic field will be kept in the top of the shaft. Then the power will be produced. Okay, this is the concept of thermal and hydro prime movers. So the thermal and hydro prime mover, so we get the final ultimate aim is to generate the power. Okay. Then as a gas turbine is a machine. So that is the first of all, what is meant by gas turbine? So we should know the fundamentals of gas turbine. Like a gas turbine. So first of all, what is meant by gas turbine? We are discussing here only. So that is a gas turbine is a machine. So delivering mechanical power or thrust. Okay. So here the gas turbine. So we see here, this is the gas turbine. So turbine means turbine, each and every turbine, not only gas turbine. So each and every steam turbine or impulse turbine, Kaplan turbine, high head turbines and low head turbine, and the medium head turbines, they are, why we are using the turbine is to generate the power. So the purpose of power, we are using the turbines. Okay. Then So we see here, this is a gas turbine is a mission. So the gas turbine is a mission delivering mechanical power or thrust. So mechanical power. So the gas turbines or any turbine will delivering the power. So will delivering the power or thrust. Thrust is in the sense of the power. Okay. So the mechanical power or thrust. It does this using a gases working fluid. Here the working fluid is a gases. So we are talking about the only that particular gas turbine. So that is the fluid, working fluid is gases. So in the steam power plant or in the steam turbines, there from steam is the working fluid. So and hydro prime movers, we have to take the hydro prime movers there from water, that is a liquid. Okay, so we have to discuss about the gas turbines. So that's why we are using the working fluid is a gas. Okay, so gases is a working fluid. And the mechanical power generated can be used by, for example, an industrial device. So the mechanical power generated can be used by, for example, an industrial device. So we can shortly call it as the ID. So that is the industrial device. We can use it in this mechanical power generation. So in this mechanical power generation, we are using the industrial devices. Okay. Then, so the outgoing gaseous fluid can be used to generate thrust. So generate thrust in the sense of the mechanical power. So thrust in the sense of the mechanical power. So mechanical energy, mechanical efficiency. Okay. So in the gas turbine, there is a continuous flow of the working fluid. So in these gas turbines, the continuous flow working fluid is gases. Okay. So efficiency. So gas turbines, that is we see the some of the important percentages. That is the efficiency is 20 to 30%, whereas that of steam power plant is 38 to 48%. So we see here the efficiency is 20. So the 20 to 30 percentage, whereas that of steam power plant is, so it is the 20 in this gas turbine have, so the efficiency is 20 to 30 percentage, but the compared to the steam power plant is 38 to 48 percentage. Major applications of gas turbine, some of the major applications we have to see here. So first I will talk about that point, the efficiency when compared to the steam power plants, which has 20 to 30%, whereas that of the steam power plant that has 38 percentage to 48 percentage. Okay, then what that value of 38 to 48, that is the efficiency, that is the thermal efficiency. So steam turbine have 38 to 48 percentage, and the coming to the gas turbines, that is 20 to 30 percentage will be there. Okay, then the major applications we have to see here, the aviation, some of the major applications of gas turbines. So that is the aviation, that is the self-contained, lightweight, don't require the cooling. So we are neglecting the coolings. So we remove it, and power generation. So this is the first point, and the second point is the power generation and oil and gases industry. So cheaper supply of fuel and low installation cost. Okay, so here the third point is oil and gases industry, the cheaper supply. So cheaper supply of fuel and low installation cost is also low. Okay, then the marine propulsion is there. Okay, then these are some of the applications regarding the gas turbine. So gas turbine power plants. Okay, then the hot gases move through a through a multi-stage gas turbine. So, okay, we see here that is the hot gases moves through a multi-stage gas turbine. Like in the steam turbine, the gas turbine also has a stationary and moving blades. So stationary and compared to the gas turbine, so that in the steam turbine have that is the some of the blades will be there. That is the turbine. So the steam turbine, the gases turbine also has stationary and moving the blades. Okay, so moving the blades. The stationary blades, so some of the examples, some of the blades of the stationary blades, the main condition, that is the guide the moving gases to the rotor blades. Okay, so the guide, that means the gaseous moving or blades, we are seeing the stationary blades, the blades guide the moving gases to the rotor blades. Okay, rotor blades. And adjust its velocity. Okay, we can adjust its velocity. Okay, then the shaft of the turbine is coupled to a generator. Okay, so the shaft of the turbine is coupled to a generator. Okay, and the main and the main working principle of the gas turbine is, we have to see here, that is the air is compressed when the time of squeezed, so to high pressure by a compressor. So by using the compressor, so air is compressed. So the air is compressed, okay, to high pressure by compressor. So with the help of the compressor, the air will be compressed. Okay, so air will be compressed means that is the air is also one of the gas. Okay, air is one of the gas. That is that's what carbon dioxide, whatever it is. But the thing is, the air is compressed with the help of the compressor. So the main function of the compressor is to compress each and every part. Okay, so the compressor, that is the air will be compressed. So the air is compressed, squeezed to high pressure by using of the compressor. Then second point is then fuel and compressed air are mixed in a combustion chamber and ignited. Okay, so this point already we studied and we read in this first unit, that is the IC engines also, the air plus fuel coming into the cylinder. So with the help of the compressor and the oil tank will be there. That oil tank, oil, we can say that the petrol or diesel or gases, whatever it is. So oil plus air. So air will air with the air compressor. So air compressor, air filter. So air filter will be there. So that air filter will move. The main thing is the air filter to send the air, and the main thing is to mix in a combustion chamber. So when the combustion chamber mixes, the burns the gases and ignited. So the main concept of this thing is, when fuel and compressed air are mixed in a combustion chamber, okay, then ignited. So and then ignited, hot gases are given off, which spin the turbine wheels. Which spin means that is a rotating. So with the spin off turbine wheels. Okay, then after completion of that one, then gas turbine burns fuel such as oil, natural gases, and polarized powders. That is the coal. Okay, we see that is the coal, or we are using the coal power plant. That is coal, and gas turbines burns fuels such as oil, natural gases, and polarized powders, that is the coal. Okay, then the gas turbine have three main parts. So here the gas turbine have three main parts, that is the air compressor, second one is combustion chamber, third one is turbine. So first of all, what is meant by air compressor? To compress the air. So air compressor is nothing but a compressor. So that compressor will compress the each and every fluid. That is, we are taking the gases, that gases is the air. So air compressor, the main function of the air compressor is to compress the air. That is by using the compressor. Okay, that is the thing. And the combustion chamber, the combustion chamber is nothing but the main part of the body, that is the inside the body, that is the combustion chamber will be created. So that combustion chamber will that combustion chamber will enter into the oil plus air mixer into the system. At that time the gases will be produced, then it is burned. Okay, after completion of the turbine. So the main function of the turbine is to generate the power. Okay, to generate the power. The turbine have some blades will be there. That blade will connected to the shaft. Shaft will connected to magnetic field. Then power will be produced. Okay. So this is some of the advantages of gas power plants. So we have to see, this is the storage of fuel requires less area, and handling is easy. The cost of maintenance is less. Okay, it is simple in construction. There is no need for boiler, so we are not using the boiler because of this is a gas turbine plant. That's why we are no need to use the boiler. If you take the steam power plants, we have to use the boiler. Okay, so and condenser and other accessories as in the case of steam power plants. Okay, then so it is a very cheaper fuel such as kerosene, paraffin, and wedges and powder. So coal can be used, which is cheaper than petrol and the diesel. So that's why we are using the gas power plants or gases we are using. That is the gas turbine plants can be used in water, saggy areas, less pollution and less water is required. Okay, these are some of the disadvantages of gas turbine power plants. That is the 60% of the power developed is used to devise the compressor. After completion of that one, so therefore the gas turbine unit has a low thermal efficiency. So the low thermal efficiency, this is one of the disadvantages of gas turbines. Okay, the running speed of a gas turbine is the range of 40,000 to 1 lakh RPM. That's why it's a major disadvantage. Why it is a major disadvantage is to whenever the speed is rotating, at the time the blades will be collapsed. Okay, that's why it's a very harmful. So that is the disadvantage. Some of the disadvantages of the gas turbine power plant. So for this reason, special mates and alloys have been used for the various parts of the turbine. High frequency noise from the compressor is objections. These are some of the disadvantages. And coming to the performance test. So in this performance test, I will discuss in the next class. Okay, thank you.